Yes, sir. This is how we are doing boiling, and the plant is semi-automatic. Wow, this is some good boiling. You can see our temperatures. That's the pressures. That is the pressure gauge, and there is our manual temperature gauge. And on the other side we have the RTD, and here we have our pneumatic valve which controls steam. And here we have our steam header gauging the pressures while balancing with a manual valve, of which you can have the PRS at the pressure reducing station to gauge. And here we have our temperatures. Yeah, we're also running well, and you can see, so that one is the stripping tower. It's stripping the fermented wash or fermented wort, and the other one, that side, this side is the rectifying tower with balancing. Also, it has a manual. We use both manual and the RTD over there. I think this side we have that RTD over there to gauge the temperatures. And these ones, you see, all these ones, that pot there, all these ones are pressure balancing pot. Yeah, these are pressure balancing lines, of which we gauge from down there at the siphon leg. And that is a storage tank for tea, the technical spirit. And this heat exchanger does the heat recovery on the material which we are sending outside. That is the spent wash. I mean the vinasse or spent wash, which is being sent outside to the waste lagoons, and we utilize that heat by first passing through the fermented wash from those two lines. You can see we first pass through so that we can increase our temperatures to around 80 or whatsoever, but around 80. This helps us on saving on steam. So we economize on steam by utilizing most of the heat which we would be taking out as waste. And this is the spent wash line coming from here, the stripping tower. Then it flows to the shell part of the heat exchanger. Yes. So this is our spirit. Yes, once it cools, it will be at 96.5. Yeah, normal. That is the normal. When it is still hot, so that this one is around 110. Yeah, the strength, alcohol strength. And this tank here you're seeing, we are still constructing, and this is a line for CIP, cleaning in place. Always while running, you expect to be cleaning your towers because of scaling. And here is our cooling tower. You can see we are running, and here is our spent wash. Those are the siphon legs, and here is our spent wash. Now we are taking to the drainage. We have already finished extracting the alcohol from this. Then we send this. Still this one, the COD content is still high. We normally tap this one to our digester system, what we call biomethanation, to our biodigester, so that we can produce a gas known as the methane gas, which we could use to produce power or heat as fuel to our steam boiler, so that we do away with firewood. And that one you see, this one here in white is coming from this rectifying tower. That is after we have stripped off the alcohol and there is that separation, fractional distillation. The liquid from the rectifying tower at the bottom will be taken out, and here we take out the what? Finesse, or we call it spent wash. Yeah. So still this thing, we can utilize this heat by preheating water, which we would be taking to boiler, so as we save on fuel, which we could be using at the boiler. So we still have work on heat recovery. And that's the reason why we, as guys who have the experience or the expertise in ethanol plants, look more at the efficiency of the plants on economic terms. Yes, by economizing. This is a steam trap. Mostly while the boiler we are running here is producing saturated steam, so we expect condensate. And condensate normally disturbs our towers up here. So you have to connect a steam trap so that most of the condensate is trapped outside. Yeah.